Tonight, I want you to imagine something unusual. Not leaving Earth, not leaving the solar system, but leaving the Milky Way itself. For most of our lives, the galaxy feels like a distant concept. We hear its name in documentaries, see glowing spiral images in books and magazines, and occasionally catch a glimpse of its pale band stretching across a dark country sky. But very few of us ever stop to think about what it would actually mean to leave it behind. The Milky Way is not just where we live. It is our entire cosmic neighborhood. Every star you have ever seen with your own eyes belongs to it. Every constellation, every bright point above a quiet summer field, every familiar pattern sailors once used to navigate oceans, all of them are part of the same enormous island of stars. And tonight, very slowly, we're going to leave that island behind. So, wherever you are right now, take a moment to get comfortable. Let the world around you grow a little quieter. And imagine yourself drifting upward, higher than the clouds, higher than the atmosphere, higher than the orbit of satellites circling Earth. Below you, the planet becomes smaller with every passing moment. The continents fade into soft shapes. The oceans merge into a deep blue sphere. Then even Earth begins to disappear. The moon slips behind you. The sun becomes just another star among countless others. And still, you continue outward. The solar system, which once felt unimaginably large, begins shrinking into a tiny pocket of light. The planets vanish one by one. Neptune disappears first, then Uranus, then Saturn and Jupiter. Eventually, even the sun becomes difficult to distinguish from the surrounding stars. And yet you have barely begun your journey, because the Milky Way is far larger than most people realize. If you could travel at the speed of light itself, the fastest speed the universe allows, it would still take you roughly 100,000 years to cross our galaxy from one side to the other. 100,000 years. Modern humans have existed for only a fraction of that time. Entire civilizations have risen and fallen in periods that would barely register on a galactic calendar, and still, the Milky Way stretches onward. As you continue moving away, more of its structure begins to reveal itself. At first, it looks like an endless sea of stars. Then patterns emerge. Dense clouds of light gather together. Dark rivers of dust cut through glowing regions. Ancient star clusters drift silently through the darkness. Nebulas shine faintly in shades of red and blue. Every direction seems filled with something. Every direction except one. Ahead, beyond the outer edge of the galaxy, the stars slowly begin to thin out. Not suddenly, not dramatically, just gradually, like the last lights of a distant city fading in your rearview mirror during a long drive through the night. The farther you travel, the more noticeable the change becomes. There are still stars around you, still glowing points scattered through the darkness, but they are no longer packed together in the way they were closer to the galactic center. The spaces between them grow larger, the darkness grows deeper, and for the first time you begin to sense something strange. The galaxy is not endless, it has an edge, not a sharp border, not a wall. Just a place where the crowded brilliance of hundreds of billions of stars slowly gives way to something quieter, something emptier. Eventually, after a journey beyond any human timescale, you look back, and there it is, the Milky Way, not as a sky full of stars, not as the glowing band seen from Earth, but as a single object, a vast spiral of light suspended in darkness, a city of hundreds of billions of suns, a structure so large that light needs 100,000 years to cross it, and yet from where you now stand, it looks small, not tiny, but smaller than you expected. A reminder that scale in the universe behaves differently than scale in everyday life. Things that seem impossibly large from the inside can appear surprisingly fragile from far away. For a moment, you might feel a sense of accomplishment. After all, you have done something almost unimaginable. You have left an entire galaxy behind. You have crossed distances so vast they defy ordinary language. Surely the difficult part is over. Surely the next destination must be close. But then you look ahead, and what you see changes everything. Because the nearest large galaxy is still 2.5 million light-years away. The Milky Way, enormous as it is, turns out to be only the beginning. And the darkness between galaxies is far worse than most people have ever imagined. The Milky Way is so familiar to us that it is easy to forget how extraordinary it really is. For thousands of years, people looked up at the pale band of light stretching across the night sky and had no idea what it was. Some cultures imagined it as a river flowing through the heavens. Others saw it as a road, a bridge, or even smoke left behind by celestial fires. The truth turned out to be stranger than any myth. That faint glow is not a cloud. It is not a river. It is not a single object at all. It is the combined light of hundreds of billions of stars spread across an enormous spiral galaxy, and we are living inside it. That last detail is important, because living inside the Milky Way makes it very difficult to understand its true size. Imagine standing in the middle of a forest that stretches beyond every horizon. You can see individual trees. You can see small clearings. You might even find a hill that gives you a better view. But no matter where you stand, you never truly see the forest itself. You are surrounded by it. The Milky Way is much the same. We know what it looks like because generations of astronomers carefully mapped its structure. From Earth, we can only observe our small corner of the galaxy. Everything else must be pieced together from observation, measurement, and patience. What emerged from that effort was a picture almost too large to comprehend. Our galaxy stretches roughly 100,000 light-years from one side to the other. To understand what that means, it helps to start with something smaller. Light travels incredibly fast. In a single second, it can circle Earth more than 7 times. In just over 8 minutes, it travels from the Sun to Earth. And yet even light, moving at the fastest speed nature allows, would need 100,000 years to cross the Milky Way. 100,000 years. If a beam of light began its journey across the galaxy when the first modern humans were painting on cave walls, it still would not have reached the opposite side today. That is the scale of the place we call home. And size is only part of the story. The Milky Way contains somewhere between 100 billion and 400 stars. No one knows the exact number. There are simply too many to count directly. Around many of those stars are planets. Some may have moons. Some may have oceans. Some may even have forms of life, looking up at their own night skies and wondering the same things we wonder. All of that exists inside a single galaxy. Just one. As you continue drifting farther away from the Milky Way, its structure becomes easier to appreciate. The bright central bulge glows softly at its heart. Spiral arms curve outward like enormous streams of starlight. Dark lanes of dust weave between them, hiding countless stars from view. The entire galaxy slowly rotates, completing one full turn over hundreds of millions of years. Nothing appears to move. Everything appears frozen. But beneath that stillness, billions of stars are traveling through space in an endless cosmic dance. Our own sun is one of them. Right now, at this very moment, the solar system is orbiting the center of the Milky Way at roughly 500,000 miles per hour. That sounds astonishingly fast. Yet, even at that speed, the sun requires about 230 million years to complete a single orbit around the galaxy. When the dinosaurs walked across Earth, our solar system was in a completely different part of the Milky Way. The galaxy was the same. The stars were the same. But our position within that vast structure was not. Everything in the universe moves. Only the timescales change. The farther you travel from the Milky Way, the more isolated it begins to appear. The nearest stars beyond its outer regions become increasingly rare. The familiar crowd of starlight starts to fade. Darkness takes over. And that darkness is surprisingly difficult for the human mind to accept. On Earth, empty space is never truly empty. There are cities beyond the horizon, clouds above, mountains in the distance. Even the deepest ocean eventually reaches a shoreline. But space does not behave that way. The universe allows emptiness on scales that have no equivalent in everyday life. You could travel for years, then centuries, then thousands of years, and still encounter almost nothing. That realization begins to change the way the Milky Way looks. From Earth, the galaxy feels enormous. From here, suspended beyond its outer edge, it feels different. It feels precious. A bright island of warmth and light surrounded by a darkness so vast that language struggles to describe it. And perhaps that is why galaxies matter so much. Not because they are the largest structures in the universe. They are not. But because galaxies are where almost everything familiar happens. Stars are born there. Planets form there. Life, as far as we know, emerges there. Galaxies are the rare places where the universe gathers enough material together to create complexity. Outside them, things become much quieter, much emptier, and much lonelier. The farther you look beyond the Milky Way, the more obvious that loneliness becomes, because ahead of you lies a region of space unlike anything found within a galaxy. A place where stars become exceptionally rare. A place where darkness dominates almost everything. A place so empty that even the word empty hardly seems adequate. To reach another galaxy, you must first cross that ocean, and it is far larger than most people realize. When most people imagine space, they imagine stars, countless stars, bright stars, distant stars, a universe crowded with glowing points of light stretching endlessly in every direction. It is an understandable picture. After all, every image we see of the cosmos seems filled with something. Galaxies spiral across telescope photographs. Nebulas glow with brilliant colors. Star clusters sparkle against black backgrounds. Everywhere we look, there appears to be activity, movement, structure, light. But there is a subtle illusion hidden within those images. The universe is not mostly made of stars. It is not mostly made of galaxies. It is not even mostly made of matter. The universe is mostly made of distance. And nowhere does that become more obvious than in the space between galaxies. As you continue drifting away from the Milky Way, the stars behind you gradually merge into a single faint glow. The great spiral galaxy that once surrounded you now hangs in the darkness like a distant lantern. Ahead, there is almost nothing. No bright clusters, no glowing clouds, no neighboring suns waiting just beyond the horizon. Only space, an ocean of it, and unlike any ocean on Earth, this one has no waves, no wind, no sound, no visible shoreline. If you could somehow stand still in the vast region between the Milky Way and Andromeda, the nearest large galaxy, the view would feel deeply unsettling. The darkness would not resemble a moonless night on Earth. It would be something far more complete, far more absolute. The nearest stars would belong to galaxies millions of light years away. Their light would still be visible, but not as individual suns. Entire galaxies would shrink into faint smudges suspended in the distance. The familiar richness of a star-filled sky would be gone. You would no longer feel surrounded by a universe full of stars. You would feel stranded between a few distant islands of light. And that feeling is surprisingly accurate. Galaxies are often described as islands in the cosmic ocean. The comparison works because oceans are mostly water, while the universe is mostly emptiness. The islands are what attract our attention. But the ocean is what dominates the map. Consider the distance between the Milky Way and Andromeda. Roughly 2.5 million light years. That number is easy to say. It is much harder to experience. Imagine crossing the United States, then imagine doing it again and again and again, until the number becomes meaningless. Now continue for millions of years at the speed of light. You are still only approaching the nearest major galaxy. The difficulty is not simply that the distance is large. It is that there is almost nothing along the way. Human beings are accustomed to journeys that pass through places. Roads connect cities. Ships cross oceans between continents. Airplanes travel between countries. Every journey contains landmarks. The universe offers no such comfort. Between galaxies, there are no destinations, no rest stops, no scenery changing outside the window, just darkness stretching endlessly ahead. In some ways, the emptiness is more remarkable than the galaxies themselves. A galaxy is easy to admire. It shines, it rotates, it forms stars, it creates planets. The void between galaxies does none of those things. It simply exists, silent and nearly invisible. Yet it occupies far more space than all the galaxies combined. If you were somehow able to scoop up a cubic meter of intergalactic space from one of these regions, you would find almost nothing inside it. On Earth, a cubic meter of air contains an unimaginable number of molecules. In the deep ocean, the same volume contains countless living organisms, minerals, and particles. Even the vacuum chambers built by scientists contain more matter than some regions of intergalactic space. Out here, there may be only a handful of atoms drifting through a volume large enough to stand inside. Perhaps fewer. The closest thing the universe offers to true emptiness. And yet even here, space is not entirely dead. A faint glow fills the darkness. Not visible to human eyes, not warm, not bright, but present. It comes from the earliest chapter of cosmic history, long before galaxies existed, long before stars were born, long before planets formed around distant suns. Nearly 14 billion years ago, the young universe was filled with brilliant light. As the universe expanded, that ancient light stretched along with it. Its wavelengths grew longer, its energy weakened. Over billions of years, it faded into a faint background whisper known as the cosmic microwave background. Today, it fills every corner of the observable universe, including the emptiest regions between galaxies. No matter where you travel, you can never fully escape it. It is the oldest light in existence, a relic from a time before any galaxy had taken shape. If you drifted through the darkness between galaxies long enough, it would become your constant companion. Not visible, not audible, but always there. A reminder that even the emptiest places still carry echoes of the beginning. The strange thing about intergalactic space is that it changes your perception of scale. Inside a galaxy, stars seem important. Outside a galaxy, stars begin to feel rare. Inside a galaxy, distances between planets seem vast. Outside a galaxy, entire solar systems become insignificant. The farther you move into the darkness, the more your perspective shifts. You stop thinking in terms of planets, then stars, then even galaxies. Eventually, all that remains is the realization that most of the universe is not made of things. It is made of separation. Separation between stars, separation between galaxies, separation between enormous structures scattered across a cosmos too large to fully imagine. And perhaps that is the most surprising truth of all. The universe is famous for its galaxies. But galaxies are not the main feature. They are the exceptions. The emptiness is the rule. And as we continue our journey outward, we are about to discover just how lonely those islands of light can become. Eventually, after crossing an almost unimaginable expanse of darkness, another island of light begins to emerge. At first, it is little more than a faint glow, a distant blur suspended against the blackness. Slowly, almost imperceptibly, it grows brighter, larger, more defined. This is Andromeda, the nearest large galaxy to our own. For generations, people have looked at Andromeda without fully realizing what they were seeing. On a dark night, far from city lights, it appears as a small hazy patch in the sky. Many people mistake it for a cloud. Some never notice it at all. Yet that faint smudge contains roughly 1 trillion stars. More stars than the Milky Way. More planets than anyone could ever count. An entire galactic civilization of suns, all compressed into a tiny patch of light visible from Earth. And still, it is 2.5 million light-years away. That distance alone would be enough to make Andromeda seem extraordinary. But what makes it truly remarkable is something else. Andromeda is close. By cosmic standards, it is astonishingly close. It is our next-door neighbor. The galaxy that sits just across the street. The easiest destination beyond the Milky Way. The most accessible large galaxy in our region of the universe. And that realization changes everything. Because if Andromeda is considered nearby, what does far away actually mean? The answer is difficult to accept. The farther astronomers looked into the universe, the more they discovered that galaxies rarely exist alone. Just as stars gather into galaxies, galaxies gather into larger families. The Milky Way and Andromeda are part of one such family known as the Local Group. This collection contains dozens of galaxies. Most are small dwarf galaxies. Some are little more than faint clusters of stars orbiting larger neighbors. Together, they form a gravitational community drifting through space. The entire Local Group stretches across roughly 10 million light-years. 10 million. And even that is still considered a relatively small structure. Imagine standing on a beach and discovering that what you thought was an ocean was actually a lake. Then discovering that the lake belongs to a river system. Then discovering that the river system belongs to an entire continent. That is what astronomy has felt like for the past century. Every time we think we understand the scale of something, a larger structure appears beyond it. The local group feels enormous until you realize it is only one small neighborhood. Beyond it lies something much larger, a vast collection of galaxy groups and clusters known as the Virgo supercluster. And beyond that, even larger structures continue to emerge. The universe seems almost reluctant to provide a final answer. Every boundary becomes the beginning of something else. Every destination becomes another starting point. And nowhere is this more obvious than when we consider how isolated galaxies truly are. People often imagine galaxies scattered evenly throughout space, like grains of sand spread across a beach. But reality looks very different. The universe resembles a collection of distant cities separated by enormous stretches of wilderness. Some regions contain many galaxies clustered together. Others contain almost none. There are places where millions of light years pass without encountering a single major galaxy. And there are places where the nearest galactic neighbor is so far away that the Milky Way and Andromeda would seem crowded by comparison. For a moment, imagine standing on a planet orbiting a star inside Andromeda. If intelligent life existed there and looked toward the Milky Way, they would see us exactly as we see them, a distant island of light, a faint spiral suspended in darkness. Their astronomers would measure the same 2.5 million light years. Their scientists would wrestle with the same impossible scale, and their dreamers might wonder whether anyone existed on the far side of that immense gulf. The symmetry is strangely comforting. Across millions of light years, two galaxies observe one another, each appearing as a small glow in the darkness, each containing hundreds of billions of stars, each separated by a distance so large that no civilization could realistically bridge it, at least not with any technology we can currently imagine. And yet Andromeda is still one of the easiest galaxies to reach in theory. That is the unsettling part, because the universe does not stop with Andromeda, not even close. As astronomers mapped larger and larger regions of space, they discovered something unexpected. Galaxies are not distributed randomly. Instead, they seem to form enormous patterns, great chains of galaxies stretching across the cosmos, immense structures woven together over billions of years. And between structures lie regions so empty that they make the space between the Milky Way and Andromeda seem almost crowded. The darkness we have crossed so far is only the beginning. Ahead lies an even lonelier universe, one where entire galaxies drift through isolation on scales that challenge the limits of imagination. And it is there, in those immense cosmic deserts, that we encounter some of the loneliest places known to exist. By this point in our journey, the distance between the Milky Way and Andromeda no longer seems quite as shocking as it did at the beginning. Not because it has become smaller, but because our perspective has changed. The universe has a strange effect on the mind. The longer you spend thinking about truly enormous scales, the more your definition of large begins to shift. 2.5 million light years still sounds extraordinary. Yet compared to what comes next, it almost feels familiar, almost comfortable. And that is where we encounter some of the loneliest places known to exist. Astronomers call them cosmic voids. The name sounds dramatic, but in many ways it is simply accurate. A cosmic void is exactly what it sounds like, a region of the universe containing far fewer galaxies than expected. Not completely empty, not entirely devoid of matter, but empty enough that the nearest galaxy may be tens of millions of light years away. To appreciate how strange this is, imagine standing in the middle of a desert. Not a desert on Earth. A desert so vast that you could travel for years without seeing another person. No towns, no roads, no signs of civilization. Now make that desert millions of times larger. Then replace the sand with darkness. That begins to approach the feeling of a cosmic void. These immense regions occupy a surprisingly large fraction of the universe. In fact, most of the cosmos is not filled with galaxies. Most of it consists of these enormous empty spaces. The galaxies and clusters that attract our attention are concentrated along vast filaments and structures, while the voids occupy much of the remaining volume. The universe is less like a solid object and more like a gigantic web. And between the threads of that web lie immense regions of almost unimaginable emptiness. Some of these voids stretch hundreds of millions of light-years across. Others are even larger, distances so great that human language begins to lose its usefulness. Because numbers alone cannot communicate what it actually feels like. The true strangeness of a void is not its size, it is its isolation. Imagine a galaxy born deep inside one of these regions, far from major clusters, far from neighboring galaxies, far from the busy intersections of the cosmic web. Such galaxies exist. Astronomers call them void galaxies, and they live remarkably lonely lives. Unlike galaxies in crowded regions, they rarely experience major collisions. They rarely interact with large neighbors. They evolve slowly, quietly, almost unnoticed by the rest of the universe. If life existed on a planet within one of these galaxies, the night sky might look very different from ours. Here on Earth, even with the naked eye, we can see Andromeda under dark conditions. A faint reminder that other galaxies exist, a distant companion shining across the darkness. But from deep within a cosmic void, that companion might not exist. There might be no visible neighboring galaxy at all, only your own. Imagine standing beneath such a sky. You look upward, you see the stars of your galaxy stretching across the heavens, you see planets, nebulas, star clusters. Everything appears normal, but beyond the edge of your galaxy, there is almost nothing. No distant spiral glowing softly in the darkness, no neighboring islands of light, only blackness. A civilization growing up beneath that sky might spend thousands of years believing their galaxy was the entire universe. And honestly, who could blame them? The evidence for anything beyond it would be extraordinarily difficult to find. The cosmos would appear empty, silent, endless. In some ways, their universe would seem much smaller than ours. And yet the reality would be exactly the opposite. They would be living inside one of the largest structures imaginable, a region of space so vast that light itself would require tens or even hundreds of millions of years to cross it. The irony is almost poetic. The larger the emptiness around you becomes, the harder it is to notice, because emptiness does not announce itself. It leaves no landmarks, no boundaries, no obvious signs, only absence, and absence is difficult to measure. Perhaps that is why cosmic voids feel so unsettling, not because they contain something frightening, but because they contain almost nothing at all. Human beings evolved in environments full of information. Forests, rivers, mountains, weather, movement. Our brains are designed to search for patterns, to identify objects, to locate threats and opportunities. A cosmic void offers none of those things. It is a place where the universe seems to have stepped back and left only silence behind. Yet even these immense voids tell us something important. They reveal that the universe is not evenly distributed. Matter gathers, clusters form, galaxies congregate in certain regions while abandoning others. Over billions of years, gravity slowly pulled material toward the great filaments of the cosmic web, leaving the voids increasingly empty. In a sense, these lonely regions were not simply born empty. They became empty. The universe gradually drained them of much of their matter, drawing it toward larger structures elsewhere. The result is a cosmos filled with contrasts, brilliant clusters of galaxies connected by delicate threads, separated by vast oceans of darkness. And the longer we study those structures, the more another realization begins to emerge. The emptiness is not standing still. The distances between galaxies are not fixed. The voids themselves are growing. Because the universe is expanding, and that expansion is making an already lonely cosmos even lonelier with every passing moment. For most of human history, people assumed the universe was static. The stars moved across the sky. Planets wandered among them. Comets occasionally appeared and disappeared. But the universe itself seemed permanent, stable, unchanging. It was easy to understand why. The night sky does not appear to expand. The stars do not visibly drift away from one another. Everything looks fixed, even eternal. But appearances can be deceptive, especially when the scales involved are measured in millions and billions of years. In the early 20th century, astronomers began discovering something unexpected. The galaxies were moving away from us. Not a few of them, not most of them, almost all of them. Wherever scientists looked, distant galaxies appeared to be receding into the darkness. And the farther away a galaxy was, the faster it seemed to be moving. At first, this was deeply confusing. It almost sounded as if Earth occupied some special place at the center of the cosmos. But that was not what the observations were revealing. The galaxies were not fleeing from us specifically. They were moving away from one another. The entire universe was expanding. To visualize this, imagine placing tiny dots on the surface of a balloon. As the balloon inflates, every dot moves away from every other dot. No single dot sits at the center of the expansion. The surface itself is growing. The distances between the dots increase automatically. Something similar is happening throughout the universe. Galaxies are not simply traveling through space. Space itself is stretching. The darkness between galaxies is growing. The cosmic ocean is becoming wider, and it has been doing so for billions of years. This realization changes the meaning of distance entirely. When we look at Andromeda tonight, we see a galaxy approximately 2.5 million light-years away. That distance feels immense. Yet Andromeda is actually one of the rare exceptions. Unlike most galaxies, it is moving toward us. The Milky Way and Andromeda are gravitationally bound together. Their mutual gravity is strong enough to overcome the expansion of space between them. In roughly 4.5 billion years, the two galaxies will begin a slow cosmic collision, not a violent crash of stars. The stars themselves are far too spread out for that. Instead, the galaxies will pass through one another like enormous clouds of light. Over billions of years, they will eventually merge into a single larger galaxy. It is one of the few major intergalactic distances that is shrinking rather than growing. Almost everywhere else, the opposite is happening. The universe is becoming more isolated, more distant. Imagine standing on a shoreline and watching the tide slowly pull away from land. At first, the change is subtle, barely noticeable. But hour after hour, the water retreats farther and farther into the distance. Something similar is happening on the largest scales imaginable. Every year, the universe becomes slightly larger than it was before. Every year, countless galaxies drift a little farther apart. The process is incredibly slow from a human perspective. No one can watch it happen with their own eyes. Yet it is one of the defining features of the cosmos. And for a long time, scientists believed gravity would eventually slow the expansion down. That seemed reasonable. Gravity pulls things together. Galaxies contain enormous amounts of mass. Surely all that matter would eventually act like a giant cosmic brake. The universe might continue expanding for a while, but eventually the expansion should begin slowing. At least that was the expectation. Then came one of the most surprising discoveries in modern astronomy. The expansion was not slowing down, it was speeding up. Somehow, the universe was expanding faster over time. Not because galaxies were becoming more energetic, not because something exploded, but because space itself appeared to be accelerating. To this day, we do not fully understand why. Astronomers call the mysterious cause dark energy. The name sounds dramatic. Yet in truth, it is simply a label for something we do not completely understand. Whatever dark energy is, it appears to make up most of the universe, and it is slowly increasing the distances between galaxies. Imagine an ocean that becomes wider every second, an ocean whose shores continuously move farther apart. That is essentially what dark energy is doing to the cosmos. The islands remain. The ocean grows. The consequences become more dramatic the farther you look. Nearby galaxies remain visible. Light from distant regions still reaches us, but there comes a point where the expansion becomes overwhelming. Beyond a certain distance, galaxies are being carried away so effectively that their future light will never reach us. Not because they cease to exist, not because they are destroyed, but because the expanding universe places them permanently out of reach. They become unreachable in the deepest possible sense. Even if a civilization could survive for billions of years, even if it possessed unimaginable technology, the gap would continue growing faster than any signal could cross it. Those galaxies would simply be lost forever. This idea is difficult to accept because it conflicts with everyday intuition. We are accustomed to thinking of distance as a challenge, a problem waiting to be solved. Cross an ocean, build a faster ship, travel farther. But some cosmic distances are not merely difficult, they are fundamentally inaccessible. Not because of engineering limitations, because of the structure of reality itself. The universe is quietly portions of itself beyond reach, and it has been doing so for billions of years. In a strange way, this means we are living during a fortunate era. The cosmos is old enough to have formed galaxies, stars, planets, and life. Yet it is still young enough that much of the universe remains visible. Future civilizations may not be so lucky. Billions upon billions of years from now, the night sky could look very different. Many of the galaxies visible today will have disappeared beyond the cosmic horizon. The universe will appear smaller, not because it actually is smaller, but because less of it will remain observable. The evidence of the wider cosmos will slowly fade away. And that future leads us to one of the most haunting possibilities in all of astronomy. A time when entire civilizations may look into the night sky and never realize how vast the universe once was. Imagine traveling forward in time, not centuries, not thousands of years, but tens of billions of years into the future, long after every nation that exists today has vanished, long after mountains have risen and eroded away countless times. Long after the sun itself has completed the final chapters of its life, the universe would still be here. Stars would still shine. Galaxies would still exist. But the night sky would tell a very different story. Tonight, when astronomers point their telescopes into the darkness, they see a universe overflowing with galaxies. Every deep image reveals countless distant islands of light. Some are spirals. Some are giant ellipticals. Some are so far away that their light began its journey before Earth even existed. Wherever we look, we find evidence that the universe extends far beyond our local neighborhood. Future astronomers may not be so fortunate. As dark energy continues stretching the cosmos, more and more galaxies will disappear beyond the observable horizon. Not all at once, not dramatically, slowly, quietly, one by one. The light they emit will take longer and longer to reach us. Eventually, the expanding universe will win the race. New photons leaving those galaxies will never arrive. The cosmic ocean will have become too wide. The distance will be growing faster than the light can cross it, and so the galaxies will fade from view. Not because they stop shining, not because they cease to exist, but because the universe itself has pulled the curtain closed. Imagine standing on a world in that distant future. You look up at the night sky. The familiar neighboring galaxies are gone. The vast cosmic web is invisible. The immense structures that once connected galaxy clusters across billions of light years have vanished beyond observation. There are no distant spirals decorating the darkness. No clues that the universe contains trillions of galaxies. Only your local galaxy remains. Everything else has disappeared. To those future observers, the cosmos would appear strangely simple. Their telescopes would reveal stars, nebulas, planets, perhaps even black holes, but the larger universe would be hidden. They might conclude that their galaxy is all that exists. And from the evidence available to them, that conclusion would seem perfectly reasonable. The expansion of the universe would have erased much of the evidence we take for granted today. In a sense, we live during a special moment in cosmic history, not because humanity is special, not because Earth occupies a privileged location, but because we happen to exist during an era when the universe is still willing to reveal its larger structure. The clues are still visible. The distant galaxies are still shining. The cosmic microwave background can still be detected. the story of the universe remains written across the sky. Future civilizations may inherit a much quieter cosmos, a cosmos that hides its own past. There is something strangely melancholy about that idea. Not tragic, just reflective. The universe is not destroying its history. It is simply allowing it to drift farther away, like ships disappearing over a distant horizon, still there, still real, but no longer visible. And eventually, only one great island of stars will remain nearby. By that time, the Milky Way and Andromeda will have completed their long dance. After billions of years of gravitational interactions, they will merge into a single enormous galaxy. The spirals we know today will be gone. In their place will stand a larger, calmer system containing the combined stars of both galaxies. Future generations, if any exist, may call this merged galaxy home. For them, it will feel enormous, just as the Milky Way feels enormous to us. Yet beyond its boundaries, the universe will seem almost empty, not because the galaxies vanished, but because the distances became too great, the cosmic ocean became too wide, the islands became too isolated. And perhaps that is the ultimate direction of the universe. Not toward chaos, not toward destruction, but toward separation. A gradual increase in loneliness, a future in which every galaxy group becomes its own isolated kingdom, surrounded by an ever-expanding sea of darkness. It is one of the strangest consequences of living in an expanding universe. The farther time moves forward, the less connected the cosmos becomes. The great structures that exist today will slowly lose sight of one another. The conversation between galaxies will grow quieter. The exchange of light will become increasingly rare. And yet, even in that distant future, something remarkable will remain. The light already traveling through space. The information already crossing the void. The ancient messages sent billions of years ago by stars, galaxies, and quasars. For despite all the emptiness, despite all the separation, the universe possesses a remarkable ability to communicate across unimaginable distances. And that communication may be the most extraordinary thing of all. For all its emptiness, the space between galaxies is not silent. At first glance, that may seem impossible. How can a region so empty contain anything at all? How can a place where atoms are separated by enormous distances still carry information across the universe? And yet it does. Right now, at this very moment, an endless stream of messages is crossing the darkness between galaxies. Most of them will never be noticed. Most will never encounter a planet. Most will continue traveling through the void for billions of years before, eventually fading into the vastness of space. But they are there, moving endlessly through the cosmic ocean. The most familiar of these messengers is light. Every star sends it. Every galaxy produces it. Every glowing object in the universe broadcasts it in every direction. When you look at Andromeda from Earth, the light entering your eyes has crossed 2.5 million light-years of intergalactic space. It began its journey long before recorded human history, long before the pyramids, long before agriculture, long before cities. The photons arriving tonight have been traveling through darkness for an almost unimaginable length of time. And somehow, they made it. That simple fact is easy to overlook. But it is extraordinary. The universe is vast beyond comprehension. The distances between galaxies are immense, yet information survives the journey. A tiny particle of light can leave a star in another galaxy, cross millions of light-years of emptiness, and eventually reach a small planet orbiting an ordinary star. In many ways, astronomy is simply the art of reading those messages. Every photon carries information. The color of a star reveals its temperature. The brightness of a galaxy reveals something about its size. The stretching of light reveals how quickly the universe is expanding. Even the faintest glow contains clues. The cosmos is constantly speaking. We have simply learned how to listen. Imagine standing on a shoreline at night. Far beyond the horizon, another lighthouse flashes. You cannot see the people operating it. You cannot hear their voices. You know nothing about their daily lives. Yet the light reaches you, and from that light alone, you learn that something exists beyond the darkness. Astronomy works in much the same way. The galaxies are unimaginably distant, but their light continues arriving, each beam carrying fragments of a story that began millions, billions, or even tens of billions of years ago. And light is not the only messenger crossing the void. The universe communicates in many different ways. Invisible radio waves travel through intergalactic space. High-energy particles race across the cosmos at nearly the speed of light. Ghostly particles called neutrinos pass through entire planets as though they were not there. Even gravity itself sends signals, ripples moving through space and time. Waves generated by colliding black holes billions of light years away. For most of human history, we knew nothing about these messages. The universe seemed quiet. Now we understand that it is filled with communication, not intentional communication, not messages sent by civilizations, but information nonetheless. Every corner of the cosmos is constantly revealing something about itself. And the remarkable thing is that intergalactic space preserves much of that information, despite the darkness, despite the enormous distances, despite billions of years of travel. The void allows these signals to pass. In a strange way, the emptiness helps. A crowded universe would be noisy, signals would scatter, light would be absorbed, information would become difficult to recover. Instead, much of the cosmos is astonishingly empty. The darkness acts like a vast transparent ocean, a medium through which ancient messages can travel almost undisturbed. This means that when astronomers observe distant galaxies, they are not merely seeing objects, they are receiving records from the past. The farther away an object is, the older the message becomes. A galaxy 1 million light-years away appears as it existed 1 million years ago. A galaxy 1 billion light-years away appears as it existed 1 billion years ago. The most distant galaxies ever observed reveal the universe as it looked shortly after the first stars were born. Distance becomes time. The cosmos transforms into a vast archive. Every direction you look reveals a different chapter of history. Nearby galaxies show the recent universe. Distant galaxies reveal ancient eras. The farthest observable light comes from a time before galaxies existed at all. It is difficult to think of another place where distance and history are so deeply connected. On Earth, traveling farther usually means moving somewhere else. In the universe, looking farther often means looking backward. The darkness between galaxies is not merely separating objects. It is preserving time itself. Layer after layer of cosmic history suspended across unimaginable distances, and perhaps that is what makes the intergalactic void so fascinating. At first it appears empty, featureless, silent, yet the longer we study it, the more we discover that it is filled with the traces of everything that has ever happened. Ancient light, ancient energy, ancient stories, crossing the darkness without rest, without interruption. Traveling onward through a universe that seems determined to separate everything, yet somehow still allows information to endure. And when we step back and look at the full picture, a deeper truth begins to emerge. The distance between galaxies is not merely a measurement. It is part of the universe's identity. It is one of the reasons the cosmos looks the way it does. One of the reasons stars, galaxies, and life exist at all. And understanding that truth requires us to take one final look at the bigger picture. As our journey comes to an end, it is worth returning to a simple question. What is the distance between galaxies? At first, the answer seems straightforward. A number, a measurement. 2.5 million light-years to Andromeda, tens of millions of light-years to more distant galaxies. Hundreds of millions between great cosmic structures. Billions across the largest observable scales. But numbers alone never tell the full story, because the distance between galaxies is not simply a measurement of space. It is a description of the universe itself. It tells us how matter gathered, how gravity shaped the cosmos, how light traveled across billions of years, and how a universe filled mostly with emptiness became capable of producing stars, planets, oceans, and eventually living beings capable of wondering about it. When we first began this journey, we left the Milky Way behind. At the time, it seemed enormous. A vast city of stars stretching across 100,000 light-years. a structure so large that light requires longer than recorded human history to cross it. And yet, as we traveled farther, even that immense galaxy became just another island. One bright patch of light suspended in a much larger darkness. Then came Andromeda, then the local group, then the realization that galaxies themselves are only small pieces of a far greater cosmic web. Each step outward revealed something surprising. The universe was not becoming more crowded. It was becoming emptier. The galaxies were not the dominant feature. The emptiness was. Most of existence is not made of stars. Most of existence is not made of planets. Most of existence is not even made of galaxies. Most of existence is distance. Vast stretches of darkness separating one island of light from another. And perhaps that is why intergalactic space feels so difficult to truly comprehend. Our minds evolved on a small world. We understand forests, mountains, rivers, cities, even oceans. But the universe operates on scales that have no equivalent in ordinary experience. There is no earthly comparison for millions of light years of near total emptiness. No familiar journey that prepares us for crossing the darkness between galaxies. The reality remains larger than intuition, and perhaps it always will. Yet despite all that emptiness, despite all that separation, something remarkable continues to happen. Light travels. Information survives. Messages cross the void. A photon can leave a distant galaxy millions of years ago and arrive here tonight. A signal generated by ancient stars can survive an intergalactic crossing that no civilization could ever physically make. The universe remains connected, not by roads, not by bridges, not by ships, but by information, by light, by the quiet persistence of physics operating across unimaginable distances. There is something deeply comforting about that. The galaxies may be isolated, the voids may be enormous, the distances may be impossible to cross. Yet the universe still finds ways to communicate with itself, photon by photon, wave by wave, across billions of years. And perhaps that is the strangest truth we have discovered tonight. The universe is both incredibly lonely and profoundly connected at the same time. The galaxies drift apart. The darkness grows wider. The cosmic ocean expands. Yet information continues moving through it. Ancient light continues arriving. The story continues being told. Somewhere in another galaxy, stars are forming right now. Planets are orbiting right now. Light is beginning journeys that may last millions or billions of years. Long after our civilization is gone, long after our species has changed, those photons will still be traveling, crossing the darkness, carrying their stories into the future. And here, on a small planet orbiting an ordinary star, in the outskirts of the Milky Way, a tiny part of the universe has become aware of itself. We look out across the void, we measure it, we study it, we wonder about it. The distances remain beyond anything we can truly imagine, but we understand enough to appreciate what they mean, enough to recognize the scale, enough to feel the wonder. The distance between galaxies is worse than most people think, far worse, not because it is dangerous, not because it is frightening, but because it is so much larger, emptier, and more profound than our instincts allow us to grasp. And yet, somehow we know it is there. We know about galaxies we will never visit. We know about light that began traveling before humanity existed. We know about structures stretching across billions of light years. That knowledge alone is extraordinary. Tonight, as the universe continues expanding around us, the galaxies continue drifting through the darkness. The cosmic web continues evolving. Ancient photons continue arriving. And beyond every horizon we can see, there is still more. More galaxies, more emptiness, more distance. A universe with no visible end. A universe still unfolding. A universe still telling its story. And for a brief moment in cosmic history, we are here to listen. Good night.